Ever notice how the edge of a shadow seems, I don't know, a bit extra dark right next to the light part?
Hmm.
It makes the lighter bit pop more. Well, that little visual trick, that's kind of a hint about what we're digging into today.
Lateral inhibition.
Exactly. Lateral inhibition in perception. Sounds technical, maybe, but it's actually a really fundamental way your nervous system works.
It really is. All about processing information.
Yeah, and we're using a set of focused questions to guide us. Our mission for you listening is to get a real handle on how this simple sounding process dramatically sharpens your senses.
And shapes how you see the world.
Right. Quickly and thoroughly. So
Got it.
let's jump in. What is lateral inhibition, basically?
Okay, so at its heart, it's the ability of a neuron that's excited, that's firing,
Yeah.
to actually reduce the activity of the neurons right next to it.
Huh. So it tells its neighbors to quiet down a bit.
Sort of. Think of it like an active process. The neuron firing strongly makes its own signal stand out by slightly dampening its neighbors.
Oh.
And this isn't just in one tiny spot. It's fundamental. It happens at, various stages all through the nervous system.
But wait, how does dampening something actually sharpen our senses? That sounds a bit backward.
Ah, good question. That's what gets really cool. It's all about contrast enhancement.
Contrast. Okay.
Imagine you've got, say, different shades of gray next to each other. Lateral inhibition basically exaggerates the difference right at the boundary.
Exaggerates.
Yeah, it makes the lighter gray seem even lighter right at the edge, and the darker gray seem even darker. The brain is actively pushing those differences.
Ah, okay. So that's why borders between things look so crisp visually.
That's a huge part of it. It's key for visual edge detection.
Right. Edges.
By making those sometimes subtle differences in light much more pronounced, it's a primary way we perceive distinct shapes, boundaries. It's like built-in edge enhancement.
Got it. So our brain isn't just passively receiving info, it's actively tweaking it. Makes sense. How did researchers actually figure this out? Was it hard to test?
Well, it involves some pretty clever experiments in neurophysiology, observing how neurons respond,
Okay.
and then seeing how that response changes based on what nearby neurons are doing. It's, a really well-established concept now, decades of work behind it.
Okay, so usually it helps us see clearly. But does this sharpening ever, go wrong? Or lead to weird effects like visual illusions?
Oh, absolutely. It's definitely a key player in some visual illusions. Take Mach bands, for instance.
Mach bands.
Yeah, if you look at a gradient, like smoothly changing gray stripes, you often see these faint, illusory light and dark lines right at the boundary between shades.
Even if the shades themselves are perfectly uniform.
Exactly. Those bands aren't really there in the image. It's because the neurons seeing the slightly darker area inhibit their neighbors seeing the slightly lighter area,
Ah.
which exaggerates the perceived difference right at that edge, creating those ghost bands.
Wow. So our own brain wiring creates stuff that isn't physically there. Is this just a vision thing, or does it happen elsewhere?
No, not just vision. That's what's so interesting. It seems to be a more general principle. You find similar processes in touch and hearing, too.
Really? Touch and hearing.
Yeah. Specifics might differ a bit, but the basic idea enhancing contrast by suppressing neighbors, that pops up elsewhere.
Okay. And given how important it is, what if the system gets damaged or just doesn't work right?
Well, if the lateral inhibition systems are impaired, things can get less distinct. Sensory experiences might seem blurred, maybe.
Blurred.
Yeah, or it could be harder to tell similar things apart.
Yeah.
The overall sensory input might just feel less defined, less sharp.
Man, it's wild how this subtle neural thing impacts everything. I think I read somewhere that this idea is even used in artificial intelligence.
That's right. It connects, definitely.
Yeah.
Artificial neural networks, AI, they actually simulate mechanisms like lateral inhibition sometimes.
Real way.
Yeah, it just shows how fundamental it is for processing sensory stuff effectively, whether you're, biological or artificial.
That's fascinating. Does the sharpening thing also affect maybe what we pay attention to? Does it make certain things grab our focus?
That's a really good point. It's thought that, yeah, maybe it does play a role in attention and salience.
How so?
Well, by making certain inputs stand out more sharply, enhancing that contrast.
Yeah.
It might help guide our brain to prioritize, to focus on what's most salient or important in everything hitting our senses, like a neural spotlight.
Huh. And could this relate at all to people who experience senses differently, like sensory overload or hypersensitivity?
That's definitely an area people are looking into, the potential role of lateral inhibition in sensory processing disorders.
Yeah.
It's plausible that variations in how this system works
Yeah.
could contribute to some of those heightened sensitivities. It might offer a biological clue for some experiences, but, research is ongoing.
Okay, so wrapping this up then.
Hmm.
Lateral inhibition is this core neural process
For now.
that's constantly fine-tuning our sensory world, boosting contrast, defining edges.
Across multiple senses.
Yeah, across different senses. It's basically a crucial sharpening tool that our nervous system uses.
Exactly. Happening all the time under the surface.
So for you listening, maybe think about how this sharpening deep down at the neural level isn't just about what you see or hear or feel, but maybe even how you focus your attention in this incredibly busy world. What other subtle, powerful biological things might be quietly shaping your everyday reality without you even noticing?